Hello, kita na yung presentation.
Yes, kita na.
Okay. Okay, so let us have here the design of pressure vessels. Okay, so you have your manuals with you. Okay, so and then tingnan na lang po doon sa pages ng pressure vessels. Okay, so when we say pressure vessels, these are simply containers containing pressurized fluid. Okay, so when we say fluid, it can be a gas or a liquid. Okay, so how do we design these pressure vessels? Okay, so meron po tayong tinatawag na thin walled at meron din na po na thick walled. Okay, so pressure vessels, they are constructed wherein it comes from a sheet of metal. So this sheet of metal, it has its corresponding thickness and then i-roll po natin. Tapos pagdudugtungin po yung dalawang dulo. Okay, to come up with say a cylindrical vessel. Okay, so yung thickness na ginagamit natin for the plate, okay, hindi po yun yung basihan para tawagin siya simply as thin walled or thick walled. Okay, so alin po yung basihan natin? We have what we call limiting criteria. T over D should be less than or equal to 0.1 to be called a thin walled vessel. Otherwise, if it exceeds 0.1, it is called a thick walled vessel. Okay? So, what is mainly the difference of this thin walled at saka yung thick walled? Okay? So, when we say thick walled, yes po, hindi pa kinig. Hello? Kaya, wait. Hello? Oh, naririnig ko. Hello? Mahina pa rin.
Right.
Kaya, kasi maximum ano na siya eh. Okay, so we have here the pressure vessel. Okay, so the design of pressure vessel, it is dependent on what we call thin walled or thick walled. Okay na ba? Okay. So, pag dinidesign po natin siya, we have to identify first whether the pressure vessel is thin-walled or thick-walled. Okay? So, to do that, we have what we call limiting criteria. Okay? So, the limiting criteria is the ratio between the thickness and the inside diameter. Again, take note that this is the inside diameter. Okay? So, T over D sub I. It should be less than or equal to 0.1 to be called a thin-walled vessel. Okay? So, thin-walled po siya if it satisfies this requirement. Okay? Otherwise, if it exceeds 0.1, it is called a thick-walled vessel. Okay? So, when we say thin-walled or thick-walled, ano po ba yung difference ng dalawa? Okay? So, when it comes to the stress, so the stress in a thin-walled cylinder subjected to a fluid pressure can be assumed to be uniform. Katulad po yung sa illustration natin dito. Okay? So, you have here the inner fiber, okay, which is directly in contact with the pressurized fluid. And ito naman po yung outside surface natin, okay, or outside wall. And then ito naman yung inside wall, okay. Kapag po yan ay thin walled, we assume that the stress on the inside wall, okay, at saka doon sa outside, they are just at the same or they are uniform. Okay? Kapag po yan ay thick wall, malaki po yung difference. Okay? Malaki yung difference, malaki yung nagkaiba ng values ng stresses nila. Okay? Alin kaya yung mas malaki if it is thick wall? Yun po bang nandito sa inner wall or yung nandoon sa labas? Anyone? Hello? Anyone
Yung,
po?
yung nasa inner wall po.
Tama, yung nasa inner wall. Okay, so why is it doon sa nasa inner wall? Kasi yun po yung directly in contact with the pressurized fluid. Okay, so kaya mas mataas doon. Pero if it is thin walled, we assume that both are the same or uniform lang. Okay? So, when we design the member, yun po yung una nating titingnan. Okay? Para po yun sa compression member natin. Okay? Meron tayong tinatawag na slenderness ratio. So, dito naman po, yung limiting criteria naman. Okay? We solve first for the limiting criteria to determine whether it is thin-walled or thick-walled. Okay? So, once alam na po natin kung ano yung klase siya as thin-walled or thick-walled, then may kanya-kanya po tayong procedure to follow in order to design the member. Okay? So when we say we design this member, the pressure vessel, usually we are after the thickness. Okay? Ang hinahanap po natin is yung thickness na yun ng plate na gagamitin. Okay? So how do we decide for this thickness? If it is thin-walled, okay, we have simply our induced stress. Okay, so we have the two induced stresses known as the circumferential stress and your longitudinal stress. Okay, so this is simply derived from force over area equal to the stress. Okay, so for the circumferential, you come up with PD over 2T, and for the longitudinal, this is PD over 4T. I hope this has been derived to you on your classes in deformable or statics. Okay, so these two, the circumferential and longitudinal stress, these are both induced stresses. Okay, circumferential stress is when you have here yung cylinder natin tapos kinat natin, okay, along its circumference. So you come up with this cross section ng nakat po natin. Okay, and the stresses on these walls, okay, is defined by this equation PD over 2T. P pertains to the pressure of the inside. Okay, we have DI is inside diameter, and then T is the thickness of the plate to be used. Okay, whereas longitudinal naman po, that is cut along the length of the cylinder. Okay, so nung nakat natin yan, ito po yung exposed na area. Okay, so yung ating pong stress along this area is measured using the equation PD divided by 40. Okay, and you call it now the longitudinal stress. So, comparing these two po, okay, parehas lang po yung equation natin dito. Magkaiba lang yung ating divisor. This is divided by 2 and this one is divided by 4. Okay, so if you are to compare the two, the circumferential versus the longitudinal stress, which is bigger? Which is bigger po? Circumferential or the longitudinal?
Circumferential po.
Okay, correct. It is the circumferential stress. This because you simply divide this by 2. This is simply half. Okay? Ito naman ay dinivide natin ng 4. So, this is bigger. Okay? So, kapag po ang ating cylinder, okay, kinat mo ng ganyan, circumferential, PD over 2T. Kapag along the length, PD over 40. And which is the more critical stress? Ito bigger stress. Okay? So, bigger po yung ating circumferential. So, this will be the basis of our design. Okay? And just like the usual na ginagawa natin, we simply equate, okay, the design stress with the induced stress of the material. Okay? So, for a good design, we equate sigma D with your circumferential stress. Again, pinili po natin yung circumferential stress kasi siya po yung mas malaki doon sa dalawang induced stresses. Okay? So, this sigma sub C would be PD over 2T. And your design stress, this can be sigma Y over factor of safety is based on yield, or it can be sigma U over factor of safety is if it is based on the ultimate strength. Okay, so any of these two po pwede natin gamitin depende sa basis po ng ating design. Okay, kung hindi po binigay ang basis ng design, again, we are after the type of material, okay, for this design stress. Again, saan po natin siya equate na induced stress? It should be on the circumferential stress, which is the bigger stress. Okay? So, PD divided by 2T. Now, there are cases that you are given a joint efficiency. Okay? So sabi ko nga kanina, it comes simply from a sheet of metal tapos ni-roll po natin tapos pinagdugtong. So ito po yung parte na pinagdugtungan niya. Okay? So paano po ba siya pagdudugtungin? It's either by a rivet or through welding. Okay? Ito, when you say welding, inaano po natin. We have there yung filler or a metal, tapos tinutunaw natin to become a filler para ma-join yung dalawang ends. Okay? And then yung rivet naman po, it is just like a screw, lamang po, wala po siyang thread. Okay? So, kumbaga po, pag aalisin natin yung rivet na yon, totally sira na din yung rivet. Hindi katulad ng screw that you need simply a screwdriver para ma-detach po ulit. Okay? Ma-disengage natin. And then anytime, pwede ulit natin na ikabit. So, yun lang po yung difference. But then, yung itsura po niya, halos ganoon din. Okay? So, you join the member, okay, or you join the ends using a rivet or through welding. Okay? So, with this joining methods, minsan may hindi siya po 100% efficient. Okay? So, nilalagay natin, may binibigay sa problem such as what we call the joint efficiency. So, if you are given a joint efficiency, you have to account that on this equation. Okay? So, isasama natin sa equation yung efficiency na yun. So, ano pong gagawin kapag may joint efficiency? Then, yung design stress po natin should be lowered. Okay? So, you make use of a lower design strength to take care of the weakening of the joints. So, instead of, di ba kanina, ginamit natin dito, sigma D equal to your circumferential stress. We simply equate the design stress to the induced stress. So, dito, ganun din naman. Okay, lamang ang gagamitin natin is the lower design stress. Okay? So, yung lower design stress, yun po yung equate natin to the induced stress, which is the circumferential stress or the bigger stress. Okay? Now, we lower the design stress again to take care of the weakening of the joints. So, dito po natin isasama yung joint efficiency. So, that would be the design stress and then you multiply that by JE. Halimbawa, if it is 90% efficient, so you use here 0.90. So it's the decimal equivalent. So in that way, you will be lowering, okay, your design stress. So it's the usual design stress, sigma U over Fs or sigma Y over factor of safety. Okay? Ngayon lang, i-multiply po natin siya ng joint efficiency to lower the value. Okay? So, at ito po yung lower design stress, siya po yung equate natin to the induced stress, which is the circumferential stress, PD divided by. Okay? So, from there, you can compute now for the corresponding thickness of the plate to be used. Okay? Now, there are cases naman po that the ano po natin, the vessel natin, the pressure vessel is in a form of a sphere. So, kalimitan po dyan, it's cylindrical in form. Okay? So, what is readily available po sa market for purchase ng mga pressure vessels, ayun po ay kalimitan ay cylindrical. Just like po yung mga water tanks po natin na ginagamit, okay? Lahat po siya ay kalimitan cylindrical kasi yun yung readily available or commercially available. Okay? There are cases po na may gumagamit din ng spherical. Meron din naman po in a form of a cube o kaya ay rectangular parallelepiped. Okay, lamang po, madalang po yung ganun. Okay, kasi if you insist on using those po, you need really to fabricate on your own. Okay, so magpapasadya ka po ng ganun ng mga korte. Okay, ganun ng mga forms. Yan. But then, ito po sphere, may ilan-ilan po nito na available sa market. Okay? Ang lamang po, this spheres po, spherical vessel, pag ginagamit po yan, that is yung ilalaman po natin sa kanya na liquid, it should be a small amount lang po. Okay? Small amount lang. Why? It will consume po a bigger space kung malaki yung volume. Okay? For a volume of a sphere, it is measured through the diameter niya or yung radius po. Okay? So, ibig sabihin, kapag masyadong malaki yung volume, it will take a lot of space kasi we need malaking diameter, okay, nung ating na sphere. So, kung gagamit siya ng space nung land para pag-store sa kanya, paglalagyan ng ating na vessel, so ano mangyayari? Napakalaking space po yung kanyang magagamit. Okay? Not unlike po kapag cylinder. Okay? Pag cylinder po, the volume of the cylinder is dependent on its diameter so as with its height. So, pwede po hindi mo baguhin yung diameter, itataas mo lang po yung height para mas malaking volume yung ma-accommodate. So, ibig sabihin, if it has the same diameter lang po, so yung space po na gagamitin mo is limited din. Okay, kasi yun lang, yun. Ang gagawin mo lang para dumami siya, patatasin mo ng mataas, okay? Yung height to accommodate more volume. Okay? So that is why it is more practical to use the cylindrical vessel rather than any other forms. Okay? So, kung thin walled po yan, kung spherical po yan, okay, the longitudinal and the circumferential stress are both PD divided by 40. Kasi yung kung imagine nyo po yung bola, hatiin mo crosswise, hatiin mo lengthwise, iisa lang naman yung magiging itsura dyan. Okay? Hindi katulad ng cylinder, pag kinat mo lengthwise, crosswise, so magkaiba yung itsura. Okay? Dito, kahit saan mo siya hatiin, pare-parehas lamang. Okay? So, for the thin-walled spherical vessel, yung longitudinal stress natin ay equal din po sa circumferential stress, which is equal to PD divided by 40. So, therefore, this would be its induced stress. Okay? Parehas lang yung dalawa. PD divided by 40. Not unlike yung sa cylinder kanina, pinili natin kung alin yung mas malaki at yun yung magiging basis natin ng design. Dito, hindi po. Okay? Parehas lang yung value. So, we simply take this value. Okay? PD divided by 40 to be equated to your design stress. Okay? So, equate mo lang po sa design stress, sigma U over Fs or sigma Y over factor of safety. At kung may dumtong po, ano po ang gagawin? You have to lower the design stress. So, instead of using sigma D, ang gagawin mo would be sigma D prime. Okay? So, you have to multiply your design stress with the joint efficiency. Ito po yan. So, sigma D prime equal to sigma D multiplied by J. Okay, question? Hello? Okay. So, ganun po natin i-design kapag po ang member natin is thin-walled. Again, yung po procedure na minention ko, yun po ay para lang sa thin-walled. Okay? Either po siya ay cylindrical o kaya po ay spherical. Okay? So, sa induced stresses, yung isa, pag siya po ay cylindrical, PD divided by 2T. Okay? Kapag po naman siya spherical, it should be PD divided by 4T. Okay? To be equated to your design stresses, sigma D. Okay? And if there is a joint efficiency given, instead of sigma D, you use sigma D prime, the lower design stress. Okay? So, that would be our procedure, okay, para po doon sa unang klase na yun, okay, the thin wall. What about naman po if we see a thick wall vessel? Okay? So, when we say thick wall, cylinder naman po, okay, yung ratio ng thickness over inside diameter is more than 0.1. Okay? And pag sinabi natin na thick wall, get mo pong stress doon sa inner walls at doon sa outer walls, malaki yung difference, malaki yung pagkakaiba. Okay? Higher po yung value doon sa in contact with the pressurized fluid. So, it's on the inner walls. Okay? Now, kapag po nakita natin na siya ay thick wall, we can no longer use po yung mga equations kanina. Okay? But instead, we will be using what we call Lam's formula or Lam's equation. Okay? The Lam's equation po is derived galing din sa thin wall. Okay? So, yung thin wall po, so thick wall po siya. So, dinivide mo po siya ng maraming thin wall. Okay? Parang dinivide mo siya sa ilang thin-walled, and then you come up with this equation, the names. Okay? So, if known to be a thin-walled cylinder, you will be using now in your design the Lames formula. Okay? So, we have here listed are the three Lames equation. Here, first is the hoop stress on the inner fiber. Okay? Sigma T sub I. And then here naman po is dun sa outside wall. That's the hoop stress on the outer fiber. And then last one po is the longitudinal stress. Okay? Paki-correct lang po nito. There should be sigma and then subscription be L. Okay? So longitudinal sigma and then subscript L. Okay? Yung una is sigma T sub I and then this one is sigma T sub O. So correct po yun. Ano lang po i-correct natin? Sigma L. Okay? Now, we look at each equation. Halimbawa po ito muna. Hoop stress on inner fiber. Okay, so what's in the equation po? Pi is the inside pressure. Okay, so the pressurized fluid inside, we assume it would be the same po doon sa wall. Okay, so that is Pi. Ri is the inside radius. Okay, so given the diameter, I simply divide that by 2 to obtain the radius. R sub O, okay, is the outside radius. And then you have their PO, okay, is the outside pressure. Okay, for the outside pressure, if this is not given, okay, just make use of the standard atmospheric pressure. Okay, standard atmospheric. Okay, so P sub O, okay, okay, you assume to use the standard atmospheric pressure if this is not given. So what is the value? It is 14.7 psi, again 14.7 psi or 101.325 kilopascal. Okay, so you take note of that. Okay, kapag po inibigay ang outside pressure, yun po yung gagamitin natin. Okay, 14.7 psi or 101.325 kPa. Okay, nakuha po ba? Nasundan po? Hello? Okay, now, so, dito, okay, yung Lames equation po, yung gagamitin. Again, this is valid only for thick wall. And when we say we design, ano po ang ating i-design? We are looking for the dimension. So, kapag pressure vessel, katulad po sinabi ko kanina, it is the thickness of the plate na ginamit mo, yun po yung ating hahanapin. Yun yung ating i-design. So, what would be the thickness? So, you see here two equations po. Okay? Equation for the thickness, one for the brittle material, and then the other one is for a ductile material. Okay? So, this is along with the Lames equation. So, here, po sa ating equation, pipili lang po with the given material kung aling equation yung gagamitin. And you look at the equation, that involves DI, that's the inside diameter. This is usually given, okay? Sigma T sub I, okay? And then PI. So, PI is usually given po, okay? That's the air pressure. And yung sigma T sub I. So, ibig sabihin, before you can solve here for the thickness, necessary that you solve first for sigma T sub I. Okay, so, need muna po natin isolve yung sigma T sub I. And where can you obtain the value of the sigma T sub I? Okay, saan po natin makukuha yung equation? Ito po yung sigma T sub I. Okay, so meaning, you need to solve this first. Tsaka po natin isa-substitute dito sa equation dito. Okay? So, ano yung sigma T sub I? So, that is equal to Pi times quantity Ri squared plus Ro squared minus 2 Rho squared over Ri minus Ro quantity squared. Okay? Yan. So, this is necessary that you solve first your sigma T sub I before po natin ma-solve yung yung value ng thickness. Okay? So, Using this equation po, okay, yung PI po, this is usually given, so as with RI. Yung RO po, hindi po yan ibibigay. Okay? RO hindi ibibigay. Kasi kung ibibigay po yung RO, we know that yung RO po natin, okay, is simply DO over 2. And to obtain yung RO, it would be RI plus the thickness. So, no need na po tayo gamitin pa itong equation na to kung masosolve naman po pala using this equation only. Ri plus t equal to RO. Nakuha po ba? Kaya ibig sabihin po, hindi po ibibigay sa given yung mga RO na yan. Okay? So, ang gagawin nyo po to solve for your sigma t sub I, you should express R sub O as to Ri plus thickness. Okay? Ri plus thickness. And thickness is what we are looking for po. So, ibig sabihin, your sigma t sub I is in terms of the variable t. Okay? It's in terms of the variable t. Tsaka mo po isa-substitute po dito yung sigma t sub I. Then you need to simplify to obtain the thickness of the plate to be used. Okay? So, yun po yung procedure natin if you have there, ano naman po, thick wall pressure vessel. Hello? Nasundan po ba? Okay, good. So, again, you would start with your limiting criteria for you to solve a problem on pressure vessel. Okay? Ano muna po ang uunahin lagi natin? T over D sub I. Ayan, the limiting criteria. Okay? Pag na-solve mo po yan, you would know if it is thin-walled or thick-walled. And once you know na po kung thin-walled or thick-walled yan, meron na kanya na po na procedure na ipo-follow sa pag-design. Okay? But then, you look at the limiting criteria once again. Okay? This is T divided by D sub I. Okay? So, it is a function of the thickness also. Okay? Para bang yung sa atin na sa compression. Okay? The slenderness ratio is a function also of the dimension. So, ito po, ganun din. Yung limiting criteria po natin, ganun din. It's a function of the unknown. Okay? So, ibig sabihin, initially, hindi mo pa uli masosolve itong limiting criteria natin. Kasi unknown po yung thickness. Okay? So, ano pong gagawin natin kapag ganoon? Hello? Hello? Ano pong gagawin natin kapag ganoon? So, sabi natin, we need to start with this one, the limiting criteria. But then, yung pong thickness na yun is still unknown. Anong gagawin doon? Hello? Narinig po?
Rinig po.
So, anong gagawin natin kapag ganun? Just like yung ginawa po natin doon sa compression. Okay? So, what you need to do is to simply assume. Okay? So, ano po yung assume natin? You simply assume thin wall. Okay? So, you assume thin wall, then you follow procedure designing ng thin wall. Once na may answer na po tayo, you need to go back to this limiting criteria. Okay? Yung na-compute po natin, yung sagot po natin, is to be substituted here, and then tingnan mo po if nag-follow po siya dito sa atin na requirement. Okay? So, kung nag-follow po siya doon sa requirement, ibig sabihin, it is really thin wall. So, yung nakuha nating dimension ay tama. Okay? Pero kung hindi po, nag-exceed po dito sa ating limiting criteria, ano ang ating isusunod na gagawin? Okay? You need to recompute using equations po para sa thick wall. At kung ano po yung ma-recompute natin, that would be po yung final answer na. Okay? So, ganun po natin ngayon i-design yung mga vessels po. Okay? So, you have here sample problems 1 and 2. Okay? I want you to work on this problem. Okay? So I want you to solve this po. I'll send a link po for the Jamboard para you can paste po your solution doon. Okay? So I'll guide you first with kung paano nyo po isi-solve yung problems. Okay? The first one, determine the bursting steam pressure of a steel shell with a diameter of 10 inches and made of 1/4 thick, this is 1/4 inch, okay, thick steel plate. The joint efficiency at this is at 70% and the tensile strength is 60 psi. So this is your sigma U, okay? So 60 psi is your sigma U. This is your JE, the joint efficiency. This is the thickness, 1/4 of an inch. And then this diameter is the inside diameter. Okay, this is inside diameter. Okay, so here you can compute first for the limiting criteria since thickness and inside diameter is given. Okay, so from there you will know kung anong i-apply po natin na equation, whether it's thick wall or thin wall. Okay, this is a steel shell, meaning this would be a spherical vessel. Okay, again, this one is a spherical vessel. And what we're asked to do or determine is to find the bursting steam pressure. Okay, at anong pressure ba siya? Anong pressure ba siya posibleng sumabog? Okay, so para po malaman natin yun, hindi po natin i-incorporate dito ang factor of safety. Okay? So, the design stress po natin, okay, is equal to the induced stress. Okay? Lamang, do sa design stress, wala po tayo ilalagay na factor of safety. Okay? Bakit po pa na ilalagay ng factor of safety? Kasi ang hinahanap po natin is simply bursting steam pressure. So, kung ilagyan mo po siya ng factor of safety, ibig sabihin, ano yan, hindi po siya sasabog. Okay? Kasi ilagyan mo ng factor of safety. So, in this particular problem po, wala po tayong ilalagay. So, the design stress would simply be equal to your tensile strength. Okay? So, yun po yung gagawin natin dito sa sample problem 1. You will be using here lower design stress kasi may binigay kong joint efficiency. Okay? And then for problem 2, determine the safe wall thickness of a 30 inches steel tank with internal pressure of 7.82 megapascal. Yield stress of the material is 275.48 and factor of safety to use is 2. Okay? So here, you will be solving this one po in terms of unit po na SI. Okay? So your answer for the thickness should be in millimeter. Okay? Millimeter. Since yung given po here are pressures and yield stresses in megapascal or in the SI unit, so we are expecting po that your answers will be in SI din po. Okay? So, ang gagawin lang po, this 30 inches, you convert this po into millimeter. Okay? And then, you find the value of the thickness. Okay? Nasundan po ba yung gagawin? Okay, so you try to solve it first po on the sheet of paper and then later paki-paste na lang po doon sa i-provide ko po na Jamboard. Okay? So, I will stop po itong presentation and then ang i-post ko po ay yung Jamboard for your solution. We have the copy naman po of this one sa ating po na manual. Okay? So, I'll send po yung link ng ating Jamboard dito sa chat box.
Half email mo ang BCAF, ano? Ano yung meeting, di ba? Kasi mahala ko sa attend ko. Yan yung kampon ko.
Okay, so on the chat box is the link for our Jamboard, wherein you can paste your solution to problems, sample problems 1 and 2 on the pressure vessel. Okay? So once you are done, kindly indicate na lang po or kindly post it here po sa Jamboard natin para ma-discuss po natin. Okay, thank you.
Kasi ako, nakakandi ako
So for problem 1, you need to solve first for the limiting criteria. Okay, T divided by D sub I.
Kaya ang sakit ko, hindi na ako punta dito.
Is buo, you need to include also the limiting criteria T over D sub I.
Okay.
So,
Opo, opo.
Pero, ako, direct. 4 minutes. Para next. Para pag next na ang mismo problem. Di ba? Oh, ano? Direct.
Okay, so I think we are until 10 o'clock only. Okay, so yung pong solution ninyo, okay, paki-post na lang po dito sa atin na Jamboard. I will be saving naman po ito. Okay, as long as you have the link, you can have your solution po posted on it. Okay, for discussion po natin by our next meeting. Nasundan? Okay, thank you. Okay, thank you.
Bali yan, pag walang plastic.
The others